10 seconds. 10, 4, 3, 2, 1, gone. How many of us voted? Only 14. Okay, let's see the answer. What is the answer? I cannot see answer. Voting is closed. Keyboard shortcut is C. There is something problem, I think. Why I cannot see how many of you voted? Anyway, so the first one answer is, what's wrong? 0, 0, 0 it shows, but I can see the 14 of us actually voted. Okay, I think it's Menti's problem, not mine. So the A is the correct answer actually. A is the correct answer because it was there is, we can see from there, if we look at all those elements are associated here. For A it is balanced both side. So 2 aluminium in this side, 2 aluminium in this side as well. Nitrate 3 here. So here 6 nitrate. Sorry, it's 6 nitrate, 2 times 3, right? 2 times 3, 6 nitrate, so 6 nitrate. So this is balanced, this is not balanced, and so on. So I'm a bit not frustrated with this Menti now. Oh, you are seeing, yeah? Yeah. Okay, so now right? So now go to another one quickly. 1636. Let me paste it here. 16361070. 16361076. So this will be the another code, 16361076. Another code, please try and see if this is the same problem is occurring now. What is correct for the following equation? Right? What is correct for the following equation? Aluminium undergoes reduction, sulfur undergoes reduction, K being oxidizer, it is not a redox reaction, or formal charge is not same on both sides. So what is correct for this reaction? And I'll give you around maybe 1 minute. I think 1 minute is good enough. $50 seconds. Faster, faster, please. 30 seconds. $20. Another 6 of us, guys. Another 6. Where are you? Another 3 faster. Okay. So 13 of us has voted, and now I don't know what's the problem. Aluminium undergoes reduction. One of us says that sulfur 4 becomes very compelled, that K is oxidizer, and 6 says that it is not a redox reaction. 1 say formal charge is not same on both sides. So now let's come from the right side. What's going on? So many police siren. So from the formal charge, we do not know the formal charge, because if we want to know the formal charge, we have to do the Lewis structure, right? We have to find out the Lewis structure first. Only then we can see whether there is formal charge difference or same or something, anything. So formal charge we cannot say. K being oxidizer. Oxidizing agent is what it gets reduced itself. If I am, I don't know, it's a good example. If I have few phones, or I have few pens with me, right? I have too much pen in me. I have 1, 2, 3, 4, 5, 6. 4 pens I have now. If I give to someone 2 pens, that I will be, left as people with less pen. So oxidizer is the same thing, that if it has to be oxidizer, it must be a reduce. It has to be reduced by reduction will happen to itself, so that it will be an oxidizer. But we see that neither aluminium nor sulfur becomes an here oxidation or reduction happens to them. Nothing, it didn't happen, right? So it is not a redox reaction, because on the both sides, right? On the both side, we see that oxidation reduction state is same. Aluminium had here 3 oxidation state, same. Positive 3. Potassium was positive 1 on this side, is positive 1 on this side. Sulfur was, I don't know, the same state, potassium oxidation state. So it did not change oxidation state, and that is why it's not an oxidation state, the oxidation reduction. All right. So if it is not an oxidation reduction, no, stop. Okay. If it is not a oxidation reduction, so what is the reaction then? What reaction is this? Anybody? Okay, go to Menti again, and then use 4767 07678111. Okay, so use this. And so what type of reaction is this? You can have 3 entry per person, and I will not know who is writing what, but I will only see what you have written. So please type in faster. All right. What do you think, that what type of reaction is this? Faster, so that there you have 1 minute to go. "40 seconds, only 2, 4, 5, 6, faster, 30 seconds left. "20 seconds left, faster. Sprint now. "10 seconds. Time's up. All right. So now how to see the, okay, good. It's so nice to see that you have actually typed, and it is not an oxidation reaction. Is it precipitation reaction? Do you think it is a precipitation reaction? Aluminium sulfate, will it become precipitated or it is dissolved? Right? It's in the solution, and that is why we should always write the state of the matter during the aqueous solid. So yeah, that is one good answer. Another is double displacement. Yes, double replacement. We don't call it replacement, we call it double replacement. Yeah, so it's double replacement. I can see more students, many of us say double displacement reaction. And ion exchange reaction, who wrote it? I told that there is of course there is an ion changing, but there is no net changes in ions, so it cannot be ion exchange. Decomposition, oh my god, cannot. Decomposition, which one you think that decomposed? Decomposed means from AB, it is getting A and B, both. But for this case, we don't see any decomposition. Reducing agent, no, nothing, no idea. Okay. But I hope that neutralization, no, neutralization occurs only when there is acid and base reaction, acid and base involved in that. Okay, so that would be that neutralization reaction. But here it's not it's not an acid or base, it's salt. Both are salt. No idea. No idea. I hope that you have some idea now, isn't it? Okay, so now we will be moving to our acid and base lecture, but I'll just the introduction because we have not much time. All right, so for acid and base, what we will be learning for acid and base quickly. Okay, hold on. Yes, our learning objectives for acid and base is the definition. We'll try to define what is acid, what is base. One thing is there are few definitions. There are three specific, definition of acid and base. There is Bronsted-Lowry, there is Arrhenius, there is Lewis. But most of the time when you will be talking about the acid and base, it is based on Bronsted and Lowry or Lewis acid and base. Because you may ask that why do we need to have 3-4 different definition of the same thing? Like this is a pen, right? We define it as a what? The object that we can write with, and it has some ink. But if we consider this is a pen, then this is what? This is also a pen, but we can just define it in a different way that we can, it can write, and it can also use for hitting someone, right? So anyway, just jokes apart. Why do we need to have different type of definition of acid and base, because when Arrhenius gave us the acid and base, it served us very nicely. But the problem was it could not define all type of acid and base. So that's why we had to have the Bronsted and Lowry. They came and give us the acid and base definition. But it is quite simple to, similar to each other. Only there are some difference, and those differences are much. It means a much. Okay, and then we will be determining the Kw, the water dissociation constant, to determine the hydrogen ion and hydroxyl ion, because from the acid we know that there will be hydrogen ion, and if there is a base there will be hydroxyl ion, and when there is hydrogen and hydroxyl ion, when there is hydrogen ion specifically, there will be a pH changes. From the foundation, we have seen it before, and we are going to see it now as well. I mean, we'll be seeing a bit more detailed actually. It's very much similar. I'm expecting it much more participation from you now. And when this acid, the dissociation is happening, that means acid when it dissociates. Dissociate means what? This means AB, this is an acid, right? It is dissociating, not AB actually. You should not show acid as AB. Let's say that acid is dissociating, and then A and H. A and H. So when it dissociates, let's say that is a weak acid. So hydrogen ion will be produced, right? And A. A is the negative ion, the conjugate base of that acid. So conjugate acid, conjugate base, we will see as well. So when it dissociates, and how much does it, why do we call it something is weak and something is strong? There is a strong and weak is in the acid as well. And how do we define the strong acid and weak acid? So these things we will be learning. And the salt hydrolysis. Now we will see that the precipitation that occurred previously, we saw that precipitation occurs, but actually why the precipitation will occur? What is the quantification? How can we calculate whether there will be precipitation or not? So this is another interesting thing that we'll be learning later on. And the salt that produced, whether it is the neutral or acidic or basic salt. Yes, in the salt as well, there is acid, base, neutral, all type of salts are there. And at the end, the most interesting thing, we'll see how the indicator works in the acid-base reaction. What are the indicators? What we do the titration, right? So we add an indicator, in the titration mediums so that it changes its color when it reaches to the end point. And those indicators are actually a kind, is a chemical as well. It's a kind of an acid, very weak acid, but the acid it is, so that it is, we will learn what is the indicator, and the color, where the color will appear, and some other interesting thing about the indicators at the end of the thing. So now let's go to the Bronsted and Lowry, acid and base. Bronsted and Lowry is defined the acid as the proton donor. This is the best actually, and it is the most simple. It is the most simple definition of acid and base, Bronsted and Lowry. Bronsted says that according to this, Bronsted acid is acid which can donate proton, and the base is the opposite thing, that accepts that proton, right? So one is giving, who is rich is giving the money, and the poor is taking the money. So it's such a simple way, right? But before this, Arrhenius gave the first definition of acid and base and says that acid is what donates proton, same thing, but base is it donates hydroxyl ion. But later on we saw that it does not, I mean, we cannot see or we do not find all the bases that donates hydroxyl ion, but still they are base. That means Arrhenius theory does not work very good in that case. So Bronsted-Lorica. And there again, there will be Lewis acid and base. That Lewis acid, it takes a pair of electrons, it accepts a pair of electrons, and the base donates a pair of electrons. It's just opposite in giving and taking, and the unit is electron for Lewis acid and Lewis base. So Lewis acid says that the acid is what it accepts or receive one pair of two electrons, that's an acid. But Bronsted base, it donates or gives one pair of electrons, that means two electrons. So that will be the Lewis acid and base. So if we look more into it, that how the acid, how can we can show, or in the graphic, the acid and base is HCl and water is very simple thing that we know. And HCl is donating the proton and water is taking this proton. And then this chlorine is becoming a negative. So if we show that, just now I was showing it, AH, right? AH. So that H comes out as it is, and this A came out, A being chloride for this case. So sometimes we will be using this analogy of AH to show that it is an acid. Just now, that's why I mentioned it here. Okay, so this is an acid because it is giving. Hold on a second, yeah. Okay, I'm back here, as you can see. So this is an acid. This is an acid, HCl, because it is taking the electrons. I mean, it is donating the hydrogen ion, and the water, in this case, is taking that hydrogen ion from this HCl. So in this case, water is the base. It's acting as base. Water is a very interesting character. Actually, it is acid, or sometimes it is a base, and its character is very funny. I mean, very interesting actually. Later we'll see more about the water, and because of this, we are alive. There is a life on Earth because of this funny character, mysterious character of water. Okay, so acid that donates the proton, right? Acid donates the proton, and this another species is not necessarily water, but it can be anything else, right? It will be taking the hydrogen ion and produces this hydronium ion. This is one thing that we should remember, or we should be familiar with, the hydronium ion, H3O. Now, we see that since it is here, the hydronium ion. Oh, so just introduce this. This is a base proton. What's going on in Kuching? There are so many postcards and the siren is ringing. So this is the base, the proton acceptor. It is accepting the proton, and then the another thing is what is after this water take up this hydrogen ion, it produces H3O plus, right? H3O plus. Now, do you see that this is having one excess amount of hydrogen in it, O plus, and since it is a plus, it is not very stable, but it is able to donate one hydrogen and becomes H3O, H2O, go back to its original position. And by this way, this is able to donate one hydrogen, right? It is able to donate one, although it's not that strong urge it feels, but it can. And that is how it can behave. After taking this proton, it can behave as an acid. But before taking an proton and becoming hydronium ion, in its base condition, it also can act as an acid later on. We'll see it. Okay, so now this is what I was talking, that hydrogen ion, since it is now 3 hydrogen in it. Oh, by the way, when we show that previously, sometimes we would see that water dissociation, right? Water dissociation would be shown in this way: hydrogen plus hydroxyl. Hydrogen plus hydroxyl. But this is not the case. In real life, hydrogen is water dissociation occurs in this way. Two water molecule will come together and then they will dissociate this H3O plus OH. Okay, plus OH. So it is not like hydrogen, because hydrogen itself is very unstable and it is difficult. This is much easier for hydrogen to stay in. So this is in real situation it happens. In the water that you look, water is actually in this form. Although pure water, very small amount, they dissociate, but when they dissociate in this way. Okay. Now, so water is dissociated. Acid is reacting with water. Water as a base, acid is giving the hydrogen and producing the hydronium ion. This hydronium ion also capable of giving one hydrogen ion, isn't it? Just now I was telling in the previous slide that hydronium ion is capable of giving one or donating one hydrogen ion. So this hydrogen ion, since it is capable of donating hydrogen ion, okay, capable of donating, so whichever species that donates hydrogen ion is an acid. From base water, it becomes to an acid now, isn't it? We can say in this way that this base, water was a base and it took up the acid and now it converted to an acid. Although it is not as strong as HCl, because HCl is strong acid and it will dissociate all, it will give up all the hydrogen it has. It will totally donate. It is very strong acid. The strong acid and weak acid depends on as much hydrogen ion is there. Hold on, yeah. So it will give up all the hydrogen ion because ACl is very strong, and then it is turning this base into an acid as well. Later on, the base is, I mean, it took up too much hydrogen that it wants to just release that. So this is becoming an acid. It is not as strong as HCl, but nonetheless, it is an acid because it's capable of giving hydrogen. And that is why it is a conjugate acid of this base, because it came from this base, mostly H2O. So that means it has a H3O now. That means the most of it is from this base. So this is a conjugate acid of this base. Conjugate acid of this base. All right. And this chloride, it can take up one hydrogen, isn't it? Because it is new, negatively charged. So it is possible that if there is a hydrogen later on nearby, because it cannot stay the whole life as a negative ion, it has to bind with someone to become stable. It has to couple with someone, right? So if there is a hydrogen ion nearby, it will bind and produce a HCl or something like that. So this is capable of taking one hydrogen ion. I'm not saying that it will take, but it is capable of taking. That means from this acid, and this chloride came from this acid. So that is why it is a conjugate base. Conjugate base of this acid. Okay, so every acid has a conjugate base, and every base has its own conjugate acid. So in a reaction, if we ask you that show the conjugate acid and base, mention it. So you should be able to find out which is the conjugate acid or base for what. Conjugate acid base pair. Again, the same thing. Ammonia is with water. Now we have seen water as a base. Just now we have seen water as a base. It is near a strong acid. This is a base. It makes me always funny that water is funny character. It near the strong acid, it is always base. Near the strong base, it is always an acid. So ammonia is a strong base, and water, when it comes near to ammonia, it acts as a base. As an acid. So it will donate the hydrogen ion to this, and ammonia will take this hydrogen ion, becomes ammonium ion and hydroxyl. So this hydroxyl is able to take up this one later on if there is nearby any hydrogen ion. So it will take up and produce H2O again, right? So this hydroxyl ion is conjugate base of water, because water is an acid here, and ammonium is able to donate this hydrogen ion. It is not that they will donate to each other, but I'm saying that they're capable of. So this ammonia is a conjugate acid of this base. So every acid, there is a conjugate acid and conjugate base for this. Okay, so I think it's simple thing. I don't need to go much into it. Bronsted acid or base. If we want to see whether it's a Bronsted acid or base, carbon dioxide, carbonate ion. This one is able to take hydrogen and then produce one bicarbonate ion, HCO3, one hydrogen, at least one hydrogen it can take and produce bicarbonate, so that it will become carbonate. So it is an acid. Sorry, it is a base, so that it can take. Same goes for hydrogen sulfide. So hydrogen H2S, the bad smelly gas. The other day in the lab, someone produced this gas. So this is, it also can take up hydrogen and produce hydrogen sulfide, and it can be an acid. It can be act as a base. This one can donate one hydrogen. It can donate one hydrogen. So this is ammonium is a base. Ammonium is a base. For bicarbonate, what is this? What do you think that it will be? Whether it's an acid or it's a base. How to go? Okay. It's almost time and nobody reply. So bicarbonate ion, we see that here it can be both acid and base too, because it can donate. It has the hydrogen to donate. Not necessarily it will donate, but it's possible that it can donate. And what is more possible is it will take that one hydrogen and become H2CO3. It will the charge it wants to remove from it, and for that case it will take up one hydrogen, and then that is how it will be carbonic acid. So it can donate and it can take up both, but most likely it will take. So you can, if somebody says, okay, it's an acid, it's a base, they will only get half mark. They have to remember, say that it is capable of both releasing and taking. By releasing, what will happen? By taking, what will happen? And that is why it is possible. It is act as a both acid or base, conjugate acid or base. So that will be the full marks for them. Acid-base property of water, that I was saying, that this is how acid water dissociate and in the water, and that is why, since water dissociate in water, so that ion product of water we can find because at some temperature, it is always constant, and this ion product constant, since it is already said it is a constant, so it's Kw, is the concentration, molar concentration, the product of the molar concentration of hydrogen ion and hydroxyl ion at a particular temperature. So when the temperature increases, only the Kw will be increased or decreased, right? So yeah, this is it for the time being. I'll see you tomorrow at 1 p.m. Oh, sorry, forgot to mention that tomorrow I will not come for this what is